Welcome back everyone to another video here on the Unknown Coder YouTube channel, and today we're coming back with another LeetCode video. This one is number 283, move zeros, and this problem is another array problem like we've been working with lately, and this one states that given in an integer array called nums, move all of the zeros to the end while maintaining its relative order of the non-zero elements. So the big thing to notice here is that it's wanting us to go ahead and, like I mentioned, move all the zeros to the end. However, the more important part is that it wants to maintain the relative order of the non-zero elements. So this basically is saying that, hey, any elements that aren't zero, we kind of expect them to be in relative order. And as you'll see in the example, it doesn't want us moving things around like a previous challenge that we did already. Also, something to note that it says is that you should do this in place without making a copy array. That literally just means we can't make any copies like we've done in previous videos, or I guess we've done most of our things in place, but it absolutely does not want you to do anything with a copy. It wants to be done in place. So let's go ahead and take a look at the example so I can show you what it means by it wants it to be in relative order. So for our first example, we're going to have a nums array equal to, and it's going to have 0, 1, 0, 3, and 12. So as the problem states, it wants us to take all of these and put them at the end of the array. So our output's going to look something like this. We have nums once again for the output equal to, and it's going to be equal to 1, 3, 12, 0, 0. So all of the zeros are at the end, as we can see here. And then the 1 was the first non-zero number, so it goes in the first index. The 3 was the second one, and 12 was the third one. So it wants us to keep this relative order. The second example is pretty silly. And the second example just gives us a nums array equal to 0. So of course the output is just going to be nums equal to 0. This is because obviously if it's already in the first index, if we move to the back, it's going to be at the end of the index. So I don't really love this second example, but it is what it is. Let's go ahead and take a look at our constraints to see if we can get any more information out of there. So for our first constraint, we have 1 is less than or equal to nums.length is less than or equal to 10 to the 4. So all of this is saying is that the length of nums is between 1 and 1000. So we're not going to have super massive arrays, but we're also not going to have check for any arrays that are size 0. So that's not a problem. Again, it's going to be a pretty small number, so nothing to worry about here. Next one says -2 raised to the 31 is less than or equal to nums of I is less than or equal to nums 2 raised to the 31 minus 1. This one just basically means that nums of I, or the values inside the array, could be very small to very large. This is basically the size or the total size of an integer. So I guess the idea here is that maybe people would try to use the largest numbers or large numbers or something. We don't need to. So just keep that in mind. You don't have to do anything tricky with integer values or anything like that. It's a pretty simple algorithm. So as we've already established, the goal of this is to go ahead and detect all of the zeros in the array and then shift them to the back while keeping the ordering of the non-zero numbers at the same exact time as doing that. And as it stated above, this problem requires us to modify the array in place, meaning we're not allowed to create a new array and simply place the elements back into the copied array, which would make things a lot easier. We could basically have a pointer at the end of the array and a pointer at the beginning, and anytime we see a 0, just put it at the end. But this is going to complicate things a little bit, but we can still technically complete this in O of n using 2 separate loops and 2 different counter values. One value is going to keep track of the index where we're replacing the values, and then one will keep track of how many zeros that we need to add at the end. We can loop through once to count the number of zeros that we found and shift our non-zeros over to the front of the array, and then loop over the second time to copy the zeros onto the end of the array. Let's go ahead and take a look at our pseudocode before walking through our example. So for our pseudocode, we're going to start out with a zero count variable and an index variable that are both at 0. Then for each value inside of nums, we're going to go ahead and see if the current value is not 0. If this is the case, we want to copy the current value to the nums of index. And also we need to increment index to know where to place the next value. Otherwise, we want to go ahead and increment the 0 count. So either if the value is not equal to 0, then we'll go ahead and replace the value at the next index and increment the index. Otherwise, we'll go ahead and have a 0 on our hands, and then we'll need to go ahead and increment the amount of zeros that we found. After we've finished counting all the zeros, we want to place the counted number of zeros at the end of the array. And that will actually conclude the entire algorithm. It returns a void, so it doesn't do anything else. So this will go ahead and modify our array in place and confirm to the problem. Let's go ahead and take a look at our example to make sure this is going to work as we expect. For our example, once again, we're going to go with nums equal to 0, 1, 0, 3, and 12. We'll start out inside the first loop at I equal to 0. Our zeros will always be equal to 0. Our index will be equal to 0. And our nums of I will also be equal to 0. So here, I is equal to 0, so we want to count up zeros plus plus. For the next iteration, I equal to 1. Our zeros so now equal to 1. Our index is still equal to 0. And our nums of I is equal to 1. So now we want to go ahead and set nums of index equal to 1, which will end up being nums of 0 equal to 1. We want to also count up on the index plus plus. For our iteration I equal 2. Our zeros is at 1, our index is now at 1, and our nums of I is equal to 0 again. So once again, we need to count zeros plus plus. Our next iteration, I equal to 3, zeros is equal to 2, index is still 1, and nums of I is equal to 3. This means we want to go ahead and set nums index equal to 3, which will end up being nums of 1 equal to 3. We need to increment our index. Now iteration 4, our zeros is still equal to 2, our index is equal to 2, and our nums of I is equal to 12. Once again, 12 is now equal to 0, so we're going to set nums of index equal to 12, which will end up being nums of 2 equal to 12. And we'll go ahead and increment index one last time. Now we've reached the end of the first loop, and our nums is going to look like 1, 3, 12, 3, 12. So as you can see, we moved the non-zero values to the first 3 indexes, and we need to go ahead and replace the last 2 indexes with zeros. So we're going to replace nums of length minus zeros with 0. We need to decrement zeros. And once again, we need to replace nums of length minus zeros equal to 0 again. Now we don't have any more zeros, so we're done. And now our nums is equal to 1, 3, 12, 0, 0, and we are finished. So this is a very simple problem. Let's go ahead and hop onto LeetCode and solve it. We'll start out with 2 variables, an int replace index. This will be set equal to 0, and an int 0 count, which will also be set to 0. Then we'll start the first for loop. For int I is equal to 0, I is less than nums.length, and I plus plus. Then we'll go ahead and check if nums of I is not equal to 0. And if it's not equal to 0, we're going to go ahead and say nums of replace index is going to be equal to nums of I. And we're going to go ahead and say replace index plus plus. Otherwise, what we want to do is we want to say 0 count plus plus, and that will end this loop. Then we need a while our 0 count is greater than 0. We want to go ahead and say nums of nums.length minus our 0 count is going to be equal to 0. And we're going to go ahead and say 0 count minus minus. And this will be the problem as long as I didn't typo anything. Let's go ahead and give it a submit. All right, there we go. We get 1 millisecond runtime, which beats 99.98. It says that there's a 0 millisecond runtime, but it does not actually exist. For some reason, LeetCode just sometimes randomly gives them out. So this is how we can go ahead and solve our move zeros in basically the fastest runtime available on LeetCode. If you feel like you've learned anything or thought this video is valuable, please leave a like, comment, and subscribe. As always, I'm Ethan, Uncoder. Have a great day, everybody, and I'll see you in the next video.